Hello everyone. In this video, I would like to go over the formulas for the sums and difference of cube and how to factor the expression involving the sum and the difference of cube. So the sums of cube is this formula right here, a cube plus b cube. You see that the last operation in this expression is the plus. So a cube plus b cube is the sum of cubes. This is the difference of cube. So they both turn out to have the formulas like this. Okay, so then what is the difference between a cube plus b cube and a plus b, all of it in the brackets cube? So a plus b, all of it in the brackets cube, you see the last operation here is you raise this sum to the exponent of 3. So that means if I substitute the number in here, you know that you have to add this number first and then raise that to the exponent 3. So in terms of factoring, you see that it turned into a plus b, a plus b, a plus b, because I follow the formulas for exponent. So if I have a power, okay, let's say I have a to the exponent n. So it means that I multiply a by itself n times. Okay, so this one is n times. So a plus b in this case is the base and 3 the exponent for this sum. So that means I expand them into a plus b times a plus b, a plus b. I distribute it, I end up with this expression. Okay, this expression, a cubed plus 3a squared b plus 3ab squared plus b cubed. So I'm not going to go over the tedious step of distributing all this term and get to this. The reason is I'm showing everyone this formulas, or we call it the special product, is totally different from this formulas here. So this one and this one, they are totally different. Okay, so if you distribute the term for these two factors, then you end up with the original expression. So if I distribute, I should end up with a cubed plus b cubed. I distribute this, I should end up with a cubed minus b cubed. So you see they are totally different from the expression above. So keep in mind that the last operation for the sum of cube is you are adding the two cubes. You're subtracting the two cubes. But for these two formulas up here, you are having the cube as your last operation. So you add it first before you take that to the exponent 3. You subtract it first before you take that to exponent 3. Okay? So there's huge difference between these two. And I expanded a bit into the sum of square. So a squared plus b squared is not equal to a plus b all of its square. So if I put a few numbers into this to clarify with everyone. So if I make a equal to 2 and b equal to 3. Okay, so a squared plus b squared equal be 2 squared plus 3 squared. So I should have 4 plus 9. Is that right? Okay. Then I should have 13 as the answer. Right? So if I put a plus b, all of it square, so that means I will have 2 plus 3, all of it square. So I should have 5 square should be equal to 25. So you see the two numbers are totally different from each other, right? So the two 13 and 25 are not equal. So therefore a squared plus b squared is a sum of square. It's not equal to this sum raised to the exponent 2. But a plus b all of it square is equal to this. So let's substitute into 2 and 3 into these formulas to see if it's actually equal to this number 25. If we substitute it into this expression. Okay, so what I will do is I will put it is 2 square plus 2 times 2 times 3 plus 3 square. Okay, because A is equal to 2 and B is equal to 3. So I should have 4 plus 12 plus 9. So then what do I get? 4 plus 12 is 16. 16 plus 9 equal to 25. So it's exactly equal to that, right? Okay, but A square plus B square turn into 2 square plus 3 square. Follow the rules for bad maths. Okay, exponent and then exponent and then addition will be my next operation. So 2 square is 4, 3 square is 9, 4 plus 9 equal to 13. So that leading to these formulas that I'm trying to remind everyone that this is a not equal. Okay, this is not equal to. This is not equal to. AQ plus BQ is not equal to A plus B, all of it in the brackets Q. The same for AQ minus BQ is not equal to A minus B, all of it to exponent 3. Okay, so now let's go into factoring. So if I have XQ plus 27, okay, so what I'm going to do is I will write this as XQ plus 3Q. So it is a sum of Q. So I'm going to apply the formula. AQ plus BQ will be equal to A plus B, A square minus AB plus B square as the formulas. All right. Okay. Then what do I do in this case? So this is the formula. So let's check. Okay. Let's check that I got this formula correct. AQ plus BQ, A plus B multiplied by A squared minus AB plus B squared. And the final expression should be equal to the exact original statement. Alright, so then I should factor it as x plus 3. A squared should be x squared minus 3x plus 9. Okay? So then it will be x squared minus AB is minus 3 times x plus 3 squared is 9. How about these formulas? How about this one, this expression? Okay, for this expression, I will write this as 2q AQ subtract 7q BQ. Alright, because I want to raise this to the exponent q. It's a perfect q. 343, 7q will give me that number. So we should double check. Yes, it is. And then I will apply the formula AN, BN. I can group the base and both raised to the same exponent. So this is important. Keep that in mind. I will apply this to this right away. I will write 2a, all of it to exponent 3, subtract 7b, all of it to the exponent 3. Alright, okay. So what is the formulas for the difference of q? AQ subtract BQ, it will be equal to A minus B, and I multiply that with A squared plus AB plus AB and plus B squared. Okay. So double check. It is the formulas that I've written here for everyone. AQ minus BQ is A minus B. All of it multiplied with A squared plus AB plus B squared. Alright, but don't forget, this is the entire A and this is the entire b. So I will have 2a minus 7b, and in this bracket I will write 2a all of it square plus 2a times 7b plus 7b all of it in the bracket square. Then my final answer should be 2a minus 7b all of it in the bracket 4a square, okay, and plus 14ab plus 49b square as the final result. Alright, so let's go to this question number 3. Can you factor the following expression? Explain why. Okay. If not, then explain why. Okay, so I have 25 AQ plus ABQ. Okay, so I have cube here. This can be a 2Q. Okay, so this is the Q. But 25, I currently have that as 5 to the exponent 2. Right? So I have it as 5 square AQ plus 2Q BQ. This, I can turn that into 2B all of it Q, but what about this number? I cannot do anything with that. Okay? So therefore, I suggest that it's not a perfect square for me to perform a factoring involving all the whole numbers as coefficient. That I mean by whole number as coefficient. You can try to put a cube root, whatever you like to do here, but for this lesson, we are concentrating on the coefficient as a whole number. So in this case, that's why I cannot factor this, unless I make it a 125. Okay, if 125, then it's a 5 cube. All right. So for the next question, 25 x squared plus 9y squared. Okay, so let's see. 5 square x squared plus 3 square y squared. Then what? Is there a formulas that involving a squared plus b squared? Is there a special formula to factor? The answer is no. Okay, an absolute no. This is just equal to each other, and that's it. Okay, so it is a sum of square, and there isn't any special formula for the sum of square. Sum of square is just equal to itself. So don't forget, remember this. Then this one just stay the way it is. So rather writing it like that, I just write 25x squared plus 9y squared. I cannot factor it. There isn't any special formulas for the sum of square. Okay, so go back to our chart that I try to show everyone here. There's no special formula for this sum. Alright. There is a special formula for the difference of square, but not for the sum of square. But there is the formulas for the sum of cube. Okay, so I hope everyone remember here. This is the sum of cube. We have this formula. Difference of cube, we have this formulas. We have difference of square, which is this formulas here. But we don't have any formula for a squared plus b squared. A squared plus b squared is just equal to itself. Alright? Okay. So let's continue on to see any other question that I have. Yes, I do have a few more, which is quite simple for us to practice. So I have x cubed minus 10q. Okay, so it asks us to factor completely, and I realize that this is a difference of q. So difference of q. If you want me to remind you of the formulas, it could be like this: a minus b, a squared plus ab plus b squared. So then I should have x minus 10 multiplied by x squared plus 10x plus 100. Okay, 10 squared is 100. So this is simple. Okay, for number 2 is the sum of cube. Difference of cube, sum of cube. So a cube plus b cube. This one I do have a formulas for this to factor. It will be equal to a plus b multiplied by a squared minus ab plus b squared. So 343 is 7 cubed. So then I can write it as a plus 7. Multiply that with a squared minus 7 times a plus 49. Alright, okay. Now 27a cubed minus aw cubed. Alright, so this one I can turn that into a 3 cube. This one I can turn that into a 2 cube. So then I can have it as 3a all of it cube subtract 2w all of it cube. Okay, then again let's write the formula down. A minus b, a squared plus ab plus b squared. And don't forget, this is your entire a, this is your entire b. So then I should have it as 3a minus 2w, and this whole thing multiply with 3a all of it square plus 3a times 2w plus 2w all of it square. Okay, my final answer should be 3a minus 2w, 3 square is 9, a square plus 6aw plus 4w square as the final answer. Alright, so don't forget to be mindful of the term 3a and 2w, and you have to raise both of this to the square. Okay, now number 4. For this number, I think there's a trick right here. 24 is not a perfect cube. What about 81? Okay, so again, go back to the trick that there's maybe a perfect square hidden somewhere in there if we perform the step called common factor. So between 81 and 24, the common factor is 3. So if I factor out the 3, then what do I get? Okay, 3 multiplied by 27a cubed plus aw cubed. Alright. Okay, you see this is very much similar to this one above, but it's just that I turn that into a sum of cube with a hidden common factors. So after I have a common factor, 3 pulling out of this bracket, I have 27 review itself as a 3 cube, 2 is a 2 cube. So the formula is a3 plus b3 will be a plus b, a squared minus ab plus b squared. Alright. Then I will write this as 3 times so I should write it as this just to make sure. So 3a all of it cubed plus 2w all of it cubed. Okay, so to remind ourselves, I should have 3a plus 2w. Then this one should be 3a all of it square plus 3a time with 2w. This one should be a minus according to the formulas, then plus this with 2w all of it square. Alright, so then I should have 3a plus 2w. In here, I raise both of this to exponent 2. Multiply this, I should have 6aw plus 2 raised to exponent 2 is 4w squared. Alright, so let's double check our answer. Yes, we got them all correct according to the formulas. Alright, okay, so for this one, I want to double check this as well. So I do have this as a plus, so I'm good. Okay, so it's good to double check our answer. A plus 7. And then here, I should have it as this. Very good. And again, pay attention to this reminder. Some question, whether or not we can factor. Given the condition that our factors, the coefficient has to be a whole number or an integer. Okay. Alright, I think I covered everything I needed to cover for the sum of difference of cube. Alright. Thank you, everyone.